Hello Stormwater designers, welcome back to Clear Creek Solutions instructional videos. It's another hydrology education. We're going to go over water quality and design as part 3. So real quick on Clear Creek Solutions, it was founded in 2005. We do software development, hydrology modeling, and stormwater modeling. There's 60 plus years of experience between the senior members, and we developed the Western Washington hydrology model, a continuous simulation model for the counties of Western Washington. Now let's get into next in the series, which is water quality. We're going to talk a little bit about water quality here. Number one thing, water must withstand certain tests of water quality. So we can't just use water and not understand what is in it, what kind of solids are in it, maybe pollutants, and the makeup of that water. That's going to be very critical, especially when it comes to our stormwater designs and use for public utilities and things like that. So problems of water quality can be encountered in planning water supply and irrigation projects, and also the disposal of wastewater. Obviously, water quality is going to play a huge component in wastewater treatment and environmental engineering. What is composed in that water? How are we going to sort it out? What methods are going to be used to treat the water and then get it back into the public supply and system? That's going to be a very important component. Also, in terms of water supplies, will it become drinking water, potable water? Will it go right back into the wastewater system or back into nature? It's very important to determine these things, and water quality tests is what we have to use. Polluted streams create problems for fish and wildlife, and it's not suited for recreation, and it can look bad in our odors. So there's many detriments to having polluted streams. Now, some of the water entering from our streams will be polluted, but it's usually a very, very small amount, and over time it'll be corrected by the natural conditions. But putting in too much polluted water into our streams, that's going to create problems over time, especially for the animals in there. You start damaging the fish and wildlife in the stream. Well, now people can't fish for them. It can't be used for food or other uses, so that damages the industry in the area. If your river looks horrible, no one wants to be in it. It's going to ruin the recreation in the area. It's going to look bad. It's going to be horrible for the reputation of the area. So fixing these things are very important, and using water quality tests is how we're able to determine what makes up the water. So chemical and bacteriologic tests are employed to determine water quality and impurities. And we'll go in much later part of the series, we'll talk about what those tests are and what they do. But those are the tests that are used to determine water quality and impurities. The effect of these impurities must be determined by scientists, water resources engineering, environmental engineers. Must determine, okay, how bad are these impurities? What are they composed of? And how do we get rid of these, or do we have to get rid of the water from the system completely? Those are important things to be evaluated. We have to evaluate the impacts to crops and human consumers and set some quality standards. So I do believe that, and engineers do believe that setting some water quality standards is very important just for the societal good as a whole. Governmental agencies are used to safeguard against pollution in water. So here's some of the governmental agencies that oversee these aspects and make sure that we have clean water for people to use. So we have the Environmental Protection Agency, which was established in the 70s. Local state agencies often take precedent as well. The Bureau of Reclamation, the Clean Water Act that was passed, and then NACWA, or the National Association of Clean Water Agencies. These different governmental agencies and acts are sort of overseen to make sure that from a national level, a top down, making sure that there's plenty of good, clean water for people to use and available for industries. Now, obviously, there's both sides to the spectrum. Without any governmental monitoring, we could run into a situation where there's just too much polluted water and can cause a lot of problems and disruptions, as we talked about in the previous part in the series. But too much governmental regulation, and it can be really hard for industries or anyone to do anything because the standards are so high. So it's important between the public and these governmental agencies to figure out what's a good middle ground to making sure we don't destroy our clean water, our environment, and cause polluted waters to enter the system, but not go too far just to stymie all forms of industry and use of that water. Let's talk about hydraulic structures. The design of these facilities utilizes civil engineering. Just like designing a bridge, designing a retaining wall, designing anything else in engineering, designing hydrologic and hydrologic structures, it's going to be using civil engineering. The dimensions and designs are determined by the hydraulic characteristics and hydrologic principles, so often using water resources engineering and hydrology to determine how much water is getting into this system, and then using some of the hydraulic engineering characteristics to determine and size these facilities. hydrologic modeling must be used to size some of these facilities. So a software package like WMSWM or WWHM 2012, there's elements in these software packages that they get certain inflow data, and then we're able to model these facilities and then contain the stormwater or serve whatever function we need to do. So common engineering materials can be found in these stormwater facilities, and some facilities, such as low impact design, use naturally occurring materials. Something like a rain garden, which is completely unengineered and relies on the natural conditions, can be used to filter stormwater. Or a facility like a bioretention facility will use some synthetic or designed soil mixtures to help filter water, but we'll use a lot of natural conditions and a lot of naturally occurring things to help filter the stormwater. So let's talk more about hydraulic structures. The optimal locations for these facilities may be modified by the project topography. Preliminary geologic investigation are an important part of project planning. So doing a geologic test and finding out what soil is on your site is going to be critical. Is it till soil? Is it outwash soil? How well is the water going to infiltrate? Where's the water table at? All these are going to play a part in your hydraulic design. The best site must be selected based on the constraints and available materials. Just like any other engineering design, okay? It has to be able to fit the project. It has to be able to fit the cost and constraints, and whatever the best option is, it must be selected to help mitigate the stormwater. So the site conditions will play a pivotal role in the design of the stormwater facility. When we can't talk about design without talking about economics. Like I said, it is easy to design a structure with unlimited funds and constraints. You can just design whatever you want. Yeah, that's great, but that never happens in the real world. Part of the skill of an engineer is to complete a design with the knowledge of the financial and project constraints as well as societal constraints. Okay, that is what really separates good engineers from great engineers. They're able to deal with problems and constraints and make something work, which happens all the time. Economic analysis and determining the most effective alternative is pivotal to project completion. So determining what these different alternatives can be, the economic cost that goes with that, and then determining which one is best suited for your project. So the cost must be less than the benefits to justify the project. You don't want to build something and have the cost be more than whatever the project benefit was going to give you. So keeping that in mind is very important with designs. So precipitation and stream flow vary quite a bit from year to year. So it can be very difficult to design these stormwater facilities just by hand. That's why we have software packages that often help us with this process. It is economically detrimental to design a facility against the worst possible flood or guarantee water supply during a drought. So designing a facility for these really crazy extremes, like the worst flood possible, or making sure there's plenty of water during a very, very dry period, designing facilities like that, it's going to cause us to make the facility way too extreme and accommodate way too many things, and the cost will be too high. So we need to design a facility that the probability of failing is small without being too costly. So it's mostly going to work for most of our stormwater events. This will keep the cost way down as opposed to designing for every stormwater event. And economic analysis and hydrologic analysis are both critical in the design of these stormwater facilities. We need to take both these things into account. So thank you for watching part 3 of the series. You can download our ultimate hydrology guide. It tells you about the different forms of hydrologic modeling. It's a cheat sheet to help you understand some of these methods, including continuous simulation, single event, and so on. It's 100% free. Just grab the guide down below, and we'll see you guys in the next video.